we're going to start seeing rational equations with what appear to be completely different denominators. And what I want you to keep in mind is that almost always the denominators are only different in appearance because one of them has a factor and the other doesn't. So before you do anything with multiplying or common denominators, I want you to first factor these things. So let's go ahead and do that. Negative 5 over omega minus 3 over omega plus 2 equals negative 10 over, and now let's factor this term, because I see a GCF of omega. And once you factor out that GCF, we have omega plus 2. And now it's pretty easy to see what our crazy ones should be, right? This needs to be an omega over omega. Over here, we need an omega plus 2 over omega plus 2. Okay, and once I carry through that multiplication, every single denominator will have the same exact, every single fraction will have the same exact denominator. Okay, so let's multiply this through. This is negative 5 omega minus 10 over our denominator, our common denominator, minus 3 omega over, again, that common denominator. And if you end up combining this step with the next one as you get more practice, that's fine. I usually do too, but I want to be clear about what's going on here. So this is the result of that multiplication. And if you take a look, all the denominators are equal, and this is an equation, which means that equal sign lets us do something very special to both sides. We're just going to cross out all these denominators. We can do that. It's like multiplying both sides by omega and omega plus 2. So what's left? We have negative 5 omega minus 10 minus 3 omega equals minus 10. Okay, so I'm going to add 10 to both sides and combine my omegas, and I get negative 8 omega equals 0. Great, this is easy to solve. Omega equals 0. Almost done, right? We need to check and see if that solution actually works. So plug it into that original one, and actually it's easier than plugging it in. Take a look at all these things. See that omega right there? If you plug a 0 in for omega, you're going to get a 5 divided by 0, right? We have a domain restriction here, which we didn't mention at the beginning. Omega can't be 0, and what else can't it be? Oh, there's something else. Over here, we see that, well, not that one. That's confusing to look at. This one. That one says omega can't be negative 2. Because if either of these two things happen, 0 or negative 2, then you will end up dividing by 0, and that's just not allowed until we get to calculus. Okay? So this, turns out, is a big old DNE. Sorry.